The Earth, our extraordinary home Earth, the third planet from the Sun, is a remarkable sphere teeming with life, diversity, and endless wonders. It is the only known planet in the universe that harbors life, a distinction that has fascinated scientists and laypeople alike for centuries. In this piece, we will journey through Earth's unique features, its formation, life-supporting systems, and the challenges it faces today. The birth of a planet Earth's story begins about 4.5 billion years ago, born from a swirling cloud of gas and dust left over after the Sun formed. Gravity pulled these particles together, eventually creating a molten sphere. Over millions of years, Earth cooled and developed layers, a solid crust, a molten mantle, and a dense iron core. The early Earth was a hostile place, bombarded by asteroids and volcanically active. It wasn't until around 3.8 billion years ago that conditions stabilized enough for the formation of oceans, laying the foundation for life. The presence of water is one of the defining features of our planet and a critical ingredient for life as we know it. A perfect balance. Earth's position and atmosphere. Earth's position in the solar system is often described as just right. Situated in the so-called Goldilocks zone, it is far enough from the Sun to avoid being scorched and close enough to maintain liquid water. This perfect balance of distance and temperature sets Earth apart from its neighbors, Venus and Mars. Another key to Earth's uniqueness is its atmosphere. Composed mainly of nitrogen, 78%, and oxygen, 21%, with traces of argon, carbon dioxide, and other gases, this blanket of air shields us from harmful solar radiation, moderates temperature, and provides the oxygen we breathe. Earth's magnetic field, generated by its spinning core, further protects us by deflecting charged particles from the Sun. The blue planet Earth is often called the blue planet because over 70% of its surface is covered in water. Oceans dominate the landscape, playing a crucial role in regulating climate, supporting marine ecosystems, and providing resources for human life. The remaining 30% of Earth's surface is land, featuring mountains, plains, deserts, and forests. These diverse landscapes are shaped by the planet's dynamic geological processes. Plate tectonics, driven by the movement of Earth's crustal plates, creates mountains, triggers earthquakes, and fuels volcanic eruptions. This constant reshaping of the land makes Earth unique among the terrestrial planets. The miracle of life on Earth began around 3.5 billion years ago, with the emergence of single-celled organisms in the oceans. Over time, these primitive life forms evolved into the incredible diversity of species we see today. Scientists believe Earth's stable climate, liquid water, and protective atmosphere were crucial for this evolutionary process. Today, Earth is home to an estimated 8.7 million species of plants, animals, and microorganisms, although many remain undiscovered. From the lush Amazon rainforest to the icy Antarctic tundra, life has adapted to thrive in nearly every environment. This biodiversity not only sustains ecosystems but also provides humanity with food, medicine, and countless other resources. Earth's life-supporting systems. The Earth operates as a complex, interconnected system where air, water, land, and life interact. These systems are essential for maintaining the planet's habitability. 1. The hydrosphere. Comprising all the water on Earth, the hydrosphere includes oceans, rivers, lakes, glaciers, and groundwater. Water cycles through evaporation, condensation, and precipitation, sustaining life and shaping landscapes. 2. The atmosphere. This protective layer of gases regulates temperature, supports photosynthesis, and distributes heat through wind and weather patterns. 3. The geosphere. Earth's solid components, the crust, mantle, and core, drive geological processes that recycle nutrients and create diverse habitats. 4. The biosphere. Encompassing all living organisms, the biosphere interacts with other systems to maintain a delicate balance essential for life. The fragility of our planet. While Earth has endured for billions of years, it is not indestructible. Human activity, especially in the last few centuries, has dramatically impacted the planet. Industrialization, deforestation, pollution, and overexploitation of resources have led to climate change, loss of biodiversity, and degradation of ecosystems. 1. Climate change. The burning of fossil fuels has increased greenhouse gas concentrations in the atmosphere, causing global temperatures to rise. This has led to melting glaciers, rising sea levels, and more frequent extreme weather events. 2. Deforestation. Clearing forests for agriculture, logging, and urbanization has reduced Earth's green cover, disrupting ecosystems and contributing to carbon dioxide accumulation. 3. Pollution. From plastic waste in the oceans to harmful chemicals in the air, pollution threatens both wildlife and human health. 4. Biodiversity loss. Habitat destruction, pollution, and climate change have led to the extinction of numerous species, weakening ecosystems' ability to recover and sustain life. A shared responsibility. Preserving Earth's health is a shared responsibility. Governments, businesses, and individuals all have roles to play in promoting sustainable practices. Simple actions like conserving water, reducing waste, and using renewable energy can collectively make a significant impact. Innovations in science and technology also offer hope. Renewable energy sources like solar and wind power, advances in recycling, and efforts to restore degraded ecosystems are all steps toward a more sustainable future. Looking beyond Earth. As humanity progresses, we are also looking beyond Earth to explore other planets. Missions to Mars, studies of exoplanets, and the search for extraterrestrial life are all part of our quest to understand the universe. However, Earth remains irreplaceable, a unique oasis in a vast, inhospitable cosmos. The more we learn about other planets, the more we appreciate the delicate balance that makes Earth special. Protecting our home is not just an environmental or ethical issue, it is essential for our survival as a species. Conclusion. Earth is more than just a planet, it is our home, a living system that sustains us and countless other species. Its beauty, diversity, and complexity are unparalleled, but its future depends on our actions today. By understanding and respecting the intricate systems that make Earth habitable, we can ensure that it continues to thrive for generations to come. As we gaze at the stars and dream of other worlds, let us not forget the incredible gift we already have, a vibrant, blue planet, spinning in the vastness of space, alive with life and endless possibilities. Jupiter. The king of planets. Jupiter, the fifth planet from the Sun, is an awe-inspiring world that captures our imagination. Known as the king of the planets, because of its enormous size, Jupiter stands as a giant in our solar system. With its powerful atmosphere, immense gravity, and array of moons, Jupiter holds countless mysteries waiting to be explored. In this exploration, we'll dive deep into Jupiter's characteristics, its dynamic atmosphere, its many moons, and the ongoing scientific missions that continue to unravel its secrets. The origins of Jupiter. Jupiter is a gas giant, meaning it is primarily composed of hydrogen and helium, much like the Sun. It formed around 4.5 billion years ago, shortly after the Sun itself took shape. Jupiter's massive size made it the first planet to form, drawing in surrounding material through its immense gravitational field. The planet's formation is still the subject of study. Scientists believe that it may have formed in the outer solar system from the icy and rocky materials that were present during the early stages of planetary formation. Its core likely consists of heavier elements, surrounded by thick layers of metallic hydrogen and helium, along with vast clouds of gas. Jupiter's enormous size. Jupiter is a true giant. Here are some of its key physical characteristics. 1. Size and diameter. Jupiter is the largest planet in the solar system, with a diameter of about 139,820 kilometers, 86,881 miles. It's more than 11 times wider than Earth. Its volume is so vast that you could fit over 1,300 Earths inside it. 2. Mass. Jupiter has a mass that is 318 times greater than Earth's. Its gravity is about 2.5 times stronger than Earth's, which means a person weighing 100 kilograms on Earth would weigh 250 kilograms on Jupiter. 3. Rotation. Despite its immense size, Jupiter has the shortest day of all the planets. It completes a full rotation in just 10 hours, causing it to have a noticeable bulge at its equator due to its fast rotation. Jupiter's composition. A gaseous world. Unlike Earth, Jupiter does not have a solid surface. Instead, it is made mostly of gas and liquid, which gives it a fluid appearance. The planet's atmospheric composition includes hydrogen and helium. About 90% of Jupiter's atmosphere is made of hydrogen, with helium making up most of the remaining 10%. These elements are the same as those found in the Sun, reinforcing Jupiter's status as a failed star. Cloud layers. Jupiter's atmosphere is divided into distinct cloud layers that appear in different colors due to varying chemical compositions and temperatures. The topmost cloud layer is made of ammonia ice, while deeper layers consist of water clouds. Great Red Spot. One of Jupiter's most famous features is the Great Red Spot, a massive storm system that has been raging for at least 400 years. It is about 1.3 times the diameter of Earth and is believed to be powered by Jupiter's internal heat and the planet's fast rotation. Jupiter's rings and magnetosphere. While Saturn is famous for its rings, Jupiter also has a ring system, though much fainter. These rings are made primarily of tiny particles of dust and ice, likely the result of small moons or asteroid impacts. Jupiter's magnetosphere is another striking feature. It is the largest in the solar system, extending millions of kilometers into space. This magnetic field is created by the motion of metallic hydrogen inside the planet, which generates powerful magnetism. The magnetosphere captures charged particles and forms radiation belts around the planet, which can be hazardous to spacecraft and satellites. Jupiter's moons. A miniature solar system. Jupiter has more than 79 known moons, making it one of the most moon-rich planets in the solar system. Some of Jupiter's moons are fascinating in their own right, and many are prime targets for scientific exploration. 1. Io. Io is the most volcanically active body in the solar system. It has hundreds of volcanoes, some of which erupt molten sulfur and create vast lava plains. The intense volcanic activity is caused by tidal forces from Jupiter's gravity, which cause Io's interior to flex and heat up. 2. Europa. Europa is one of the most intriguing moons in the search for life. Beneath its icy crust, Europa may harbor a subsurface ocean. Scientists believe that this ocean, kept liquid by heat from tidal forces, could potentially support microbial life. 3. Ganymede. Ganymede is the largest moon in the solar system, even bigger than Mercury. It has a magnetic field of its own, making it unique among moons. Like Europa, Ganymede is believed to have an ocean beneath its icy surface. 4. Callisto. Callisto is heavily cratered, with little geologic activity. Its surface is composed primarily of water ice, and it is thought to have a subsurface ocean as well. Despite its lack of volcanic activity, Callisto is still a valuable target for study due to its potential for harboring life. The storms of Jupiter. Jupiter's atmosphere is home to powerful storms. The Great Red Spot, which we mentioned earlier, is just one of many storms that rage on the planet. In addition to the Great Red Spot, Jupiter experiences other massive storms, including Oval Ba, Red Spot Jr. Oval Ba, sometimes called Red Spot Jr., is a storm system that appeared in 2000. It began as a series of smaller storms that eventually merged into a single large storm. Its reddish color is similar to the Great Red Spot. Lightning. Jupiter experiences frequent lightning storms. In fact, lightning strikes on Jupiter are up to 1,000 times more powerful than those on Earth. These storms are driven by the intense heat and turbulent atmosphere. Jupiter's atmospheric dynamics. Jupiter's atmosphere is in constant motion due to its rapid rotation and the immense heat generated by the planet's interior. These forces create some of the most extreme weather patterns in the solar system. Jet streams. Jupiter has several bands of wind that move at different speeds, creating jet streams. These jet streams are responsible for the planet's distinct cloud bands. They also contribute to the formation of the Great Red Spot and other storms. Temperature. The upper atmosphere of Jupiter is extremely cold, with temperatures reaching 145 degrees Celsius, 234 degrees Fahrenheit. However, as you move deeper into the atmosphere, the temperature rises due to the pressure from the layers of gas and the heat from the planet's interior. Jupiter's role in the solar system. Jupiter's large size and powerful gravitational field have a profound influence on the solar system. For instance, Jupiter's gravity may have helped protect Earth from catastrophic asteroid impacts by deflecting some of these objects away from our planet. However, Jupiter's gravity can also send some objects, like comets and asteroids, into the inner solar system, where they may impact planets like Earth. Moreover, Jupiter's massive size and gravitational pull have shaped the orbits of other objects in the solar system, including the asteroid belt. The planet's presence is a key factor in the distribution of mass throughout the solar system. Exploring Jupiter. past, present, and future missions. Jupiter has been a target for scientific exploration for decades. Here are some notable missions. 1. Parker Solar Probe. Though primarily focused on studying the Sun, this mission also provided new insights into the outer reaches of Jupiter's magnetosphere. 2. Juno Mission. NASA's Juno spacecraft, which entered Jupiter's orbit in 2016, is currently studying the planet's composition, gravity field, magnetic field, and polar atmosphere. Juno's data will help scientists understand the planet's formation and the dynamics of its atmosphere. 3. Galileo Mission. Launched in 1989, the Galileo spacecraft studied Jupiter and its moons for several years, providing valuable information about the planet's moons, especially Europa and Ganymede. Looking forward, missions like the upcoming Europa Clipper mission are poised to dive deeper into the exploration of Jupiter's moons, particularly Europa, which may hold the key to finding life beyond Earth. Jupiter and human culture. Jupiter has also made its mark in human culture. In Roman mythology, Jupiter was the king of the gods, which is reflected in the planet's name. The planet has inspired countless works of art, literature, and science fiction. In modern times, Jupiter has been a symbol of power, mystery, and exploration. Its giant size and formidable presence make it one of the most captivating objects in the night sky. Conclusion: Jupiter is a planet of extremes, massive in size, rich in mystery, and powerful in its gravitational influence. From its stormy atmosphere to its fascinating moons, Jupiter continues to be a central figure in the exploration of the solar system. As missions like Juno and Europa Clipper gather data, our understanding of this gas giant will only grow, revealing even more about its dynamic processes, its moons, and the role it plays in the solar system. As we look up at the night sky, Jupiter stands as a reminder of the scale and beauty of the universe, offering a glimpse into the distant reaches of space and the possibilities that lie ahead in our journey of discovery. Neptune. The mysterious blue world Neptune, the eighth planet from the Sun, is a distant, icy giant shrouded in mystery. Known for its striking blue color and turbulent atmosphere, Neptune is the farthest planet in our solar system. Despite its distance, this enigmatic world has captured the attention of astronomers and space enthusiasts alike. Discovery of Neptune. Unlike most planets, Neptune was not discovered through direct observation. Instead, it was found through mathematical predictions. In the early 19th century, scientists noticed irregularities in Uranus's orbit, suggesting the presence of another planet exerting a gravitational pull. In 1846, Johann Galle used these calculations to locate Neptune, making it the first planet discovered through mathematics rather than a telescope. This discovery marked a significant milestone in astronomy. Physical characteristics of Neptune. 1. Size and composition. Neptune is the fourth largest planet in diameter, with a diameter of about 49,244 kilometers, 30,598 miles. Like its neighbor Uranus, Neptune is an ice giant, composed primarily of hydrogen, helium, and traces of methane, which gives the planet its deep blue color. 2. Mass and gravity. Neptune is 17 times more massive than Earth but has a surface gravity only slightly stronger than ours due to its larger size. This means you would weigh a little more on Neptune than on Earth. 3. Atmosphere. Neptune's atmosphere is thick and dynamic, composed mostly of hydrogen and helium, with about 2% methane. The methane absorbs red light, giving Neptune its vivid blue appearance. 4. Temperature. Neptune is incredibly cold, with average temperatures around 214 degrees Celsius, 353 degrees Fahrenheit. Despite its frigid temperatures, the planet radiates more heat than it receives from the Sun, likely due to internal processes. Neptune's dynamic weather. Neptune is home to the fastest winds in the solar system, reaching speeds of up to 2,100 kilometers per hour, 1,300 miles per hour. These winds create dramatic storms and weather patterns. 1. The Great Dark Spot. Similar to Jupiter's Great Red Spot, Neptune's Great Dark Spot was a massive storm system observed during the Voyager 2 flyby in 1989. Though it disappeared a few years later, other dark spots have since been observed. 2. Clouds. Neptune's atmosphere features bright, high-altitude clouds of frozen methane that form and dissipate rapidly, adding to the planet's dynamic appearance. 3. Seasons. Neptune experiences long seasons due to its tilted axis and 165-year orbital period. Each season lasts over 40 Earth years, with dramatic temperature changes occurring over these long spans of time. The rings of Neptune, while not as prominent as Saturn's, Neptune has a system of faint rings made of dust and ice particles. These rings are thought to be relatively young and short-lived, constantly replenished by debris from Neptune's moons. 1. Main rings. The rings are divided into 5 main sections: Gale, Leverrier, Lassell, Arago, and Adams. The Adams ring is particularly interesting, as it contains bright arcs, dense regions within the ring system. 2. Formation. The rings are believed to have formed from debris resulting from collisions between Neptune's moons or other objects in its orbit. Neptune's moons. Neptune has 14 known moons, most of which are small and irregularly shaped. Its largest moon, Triton, is one of the most fascinating objects in the solar system. 1. Triton. Triton is unique among large moons because it orbits Neptune in the opposite direction of the planet's rotation, a phenomenon known as retrograde orbit. This suggests that Triton was likely captured by Neptune's gravity, rather than forming alongside the planet. Surface. Triton's surface is covered with frozen nitrogen and features active geysers that eject plumes of nitrogen gas, making it one of the few geologically active moons in the solar system. Potential for life. Beneath Triton's icy crust, there may be a subsurface ocean, raising the possibility of life in its hidden depths. 2. Other moons. Neptune's smaller moons, such as Proteus, Nereid, and Larissa, are less well studied but contribute to the planet's complex gravitational dynamics. Neptune's place in the solar system. 1. Orbit and distance. Neptune orbits the Sun at an average distance of 4.5 billion kilometers, 2.8 billion miles, making it the most distant planet. A single orbit takes 165 Earth years, meaning Neptune has completed only one orbit since its discovery in 1846. 2. Magnetic field. Neptune's magnetic field is tilted and offset from its rotational axis, creating a complex and dynamic magnetosphere. This unusual magnetic field may be caused by the movement of conductive materials in the planet's interior. Exploration of Neptune. Due to its distance, Neptune has been visited by only one spacecraft, Voyager 2. 1. Voyager 2 flyby. In 1989, Voyager 2 provided humanity's first and only close-up views of Neptune. The spacecraft captured stunning images of the planet, its rings, and its moons, revolutionizing our understanding of this distant world. 2. Future missions. While there are no current missions to Neptune, scientists are eager to return. Proposed missions aim to study the planet's atmosphere, rings, and moons in greater detail, as well as explore Triton's potential subsurface ocean. Neptune in human culture. Named after the Roman god of the sea, Neptune has long been associated with water and mystery. Its vibrant blue color and remote location evoke a sense of wonder and curiosity, inspiring artists, writers, and scientists alike. Why study Neptune? Neptune represents the outer frontier of the solar system's planets. Studying Neptune and its moons can provide insights into the formation of the solar system, the behavior of ice giants, and the conditions that might support life on icy moons like Triton. Conclusion. Neptune, the distant ice giant, is a world of extremes and enigmas. From its supersonic winds to its captivating moons, Neptune continues to challenge our understanding of planetary science. As technology advances, future missions may unlock the secrets of this remote planet, offering new discoveries and perhaps even answering the age-old question of whether we are alone in the universe. The Moon. Earth's loyal companion. The Moon, Earth's only natural satellite, has captivated human imagination for millennia. Its serene glow illuminates our nights, inspires countless myths, and plays a vital role in our planet's dynamics. Despite its seemingly quiet presence, the Moon has a fascinating history, a dynamic relationship with Earth, and an enduring influence on life as we know it. In this exploration, we'll journey through the Moon's origin, its physical features, its impact on Earth, and its significance in science and culture. The birth of the Moon. The Moon's story begins around 4.5 billion years ago, shortly after the formation of the solar system. The prevailing theory, known as the giant impact hypothesis, suggests that a Mars-sized object, named Theia, collided with the young Earth. The collision ejected a massive amount of debris into orbit around our planet. Over time, this debris coalesced under the influence of gravity, forming the Moon. This fiery birth left the Moon with a molten surface, which gradually cooled to form a crust. Evidence of its tumultuous origins can still be seen today in the form of craters, mountains, and vast plains known as maria, Latin for seas, created by ancient volcanic activity. Physical characteristics of the Moon is a stark and desolate world, vastly different from Earth. It is about 1/4 the size of Earth, with a diameter of approximately 3,474 kilometers, 2,159 miles. Its surface is covered in regolith, a layer of fine, powdery dust and rocky debris formed by billions of years of impacts from meteoroids and asteroids. Key features of the Moon include 1. Craters. The Moon's surface is marked by countless craters of various sizes, caused by impacts over billions of years. Unlike Earth, the Moon has no atmosphere to burn up incoming objects or weather to erode these marks, preserving its ancient history. 2. Maria. These dark, flat plains were formed by ancient lava flows and make up about 16% of the Moon's surface. They are most visible to the naked eye from Earth and were once thought to be seas. 3. Highlands. The lighter, mountainous regions are older and more heavily cratered than the maria, representing the Moon's original crust. 4. Poles. The Moon's poles are of particular interest because they contain permanently shadowed craters where water ice has been detected, a valuable resource for future lunar exploration. The Moon's orbit and phases. The Moon orbits Earth at an average distance of about 384,400 kilometers, 238,855 miles. Its orbit is not a perfect circle but an ellipse, causing slight variations in its apparent size when viewed from Earth. This orbit, combined with the Moon's synchronous rotation, ensures that the same side of the Moon always faces Earth, a phenomenon known as tidal locking. The changing positions of the Moon, Earth, and Sun give rise to the Moon's phases. Over approximately 29.5 days, the Moon transitions through new Moon. When the Moon is between Earth and the Sun, its illuminated side faces away from us. First quarter. Half of the Moon's disk is illuminated as it orbits Earth. Full Moon. The entire face of the Moon is illuminated when Earth is between the Moon and the Sun. Last quarter. The opposite half of the Moon's disk is visible. These phases have guided human activities for centuries, influencing calendars, agriculture, and cultural traditions. The Moon's influence on Earth. The Moon's impact on Earth extends far beyond its beauty in the night sky. It plays a crucial role in stabilizing our planet and supporting life. 1. Tides. The Moon's gravitational pull creates ocean tides, which are essential for marine ecosystems. The rhythmic rise and fall of tides have also shaped coastlines and influenced human settlements. 2. Stabilizing Earth's axis. The Moon helps maintain the tilt of Earth's axis, which is responsible for our seasons. Without the Moon, Earth's tilt could vary chaotically, leading to extreme climate changes. 3. Lengthening days. Over billions of years, the Moon's gravitational interaction with Earth has gradually slowed our planet's rotation, making days longer. This process continues today, albeit at an imperceptibly slow rate. The Moon in human history and culture. For as long as humans have gazed at the sky, the Moon has been a source of wonder and inspiration. It has played a central role in mythology, religion, and art across cultures. Mythology. Many ancient civilizations associated the Moon with deities. In Greek mythology, Selene was the goddess of the Moon, while in Hindu tradition, Chandra is the lunar god. Calendars. The lunar cycle formed the basis of many early calendars, such as the Islamic and Chinese calendars, which are still in use today. Art and literature. The Moon has inspired countless works of art, poetry, and music, symbolizing romance, mystery, and melancholy. The Moon's influence extends to modern times, appearing in everything from literature and film to science fiction. The Moon and space exploration. The Moon has long been a focus of human exploration, both as a destination and as a stepping stone to the wider cosmos. Key milestones in lunar exploration include 1. The space race. In the 1960s, the United States and the Soviet Union competed to achieve dominance in space exploration. This rivalry culminated in NASA's Apollo program, which successfully landed humans on the Moon. 2. Apollo 11. On July 20, 1969, astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the moon. Armstrong's words, "That's one small step for a man, one giant leap for mankind," marked a historic moment for humanity. 3. Scientific discoveries. Lunar missions have provided invaluable insights into the moon's composition, history, and potential resources. Samples brought back by astronauts revealed the moon's volcanic history and the presence of rare minerals. 4. Future exploration. Today, space agencies like NASA, ESA, and private companies are planning new missions to the moon. Initiatives like NASA's Artemis program aim to establish a sustainable human presence on the moon, paving the way for future missions to Mars. The moon's role in science and innovation. The moon serves as both a laboratory and a stepping stone for scientific discovery and technological innovation. 1. Astronomy. The moon's lack of atmosphere makes it an excellent location for telescopes, providing clear views of the cosmos. 2. Resource utilization. Water ice at the moon's poles could be used to produce oxygen, water, and rocket fuel, supporting long-term human exploration. 3. Understanding Earth. Studying the moon helps scientists understand Earth's formation, as the two bodies share a connected history. Challenges of lunar exploration. Despite its proximity, exploring the moon is not without challenges. Its lack of atmosphere exposes it to extreme temperatures, harmful radiation, and frequent micrometeoroid impacts. These harsh conditions require advanced technology to protect astronauts and equipment. A symbol of unity and hope. The moon has a unique ability to inspire unity and hope. It belongs to no single nation or culture, serving as a shared symbol for all humanity. Lunar exploration, particularly the Apollo missions, demonstrated what humans can achieve through collaboration and determination. Conclusion. The moon is more than a celestial body. It is a cornerstone of our planet's stability, a mirror of our past, and a gateway to our future. Its influence is woven into the fabric of life on Earth, shaping our environment, our cultures, and our ambitions. As we look up at the moon, we see more than just a glowing orb. We see a reflection of humanity's enduring curiosity and potential. Whether as a muse for poets or a destination for explorers, the moon continues to inspire us, reminding us of our place in the universe and the infinite possibilities that lie beyond. Mars. The mysterious red planet Mars, the fourth planet from the Sun, has fascinated humans for centuries. Often called the Red Planet, due to its distinctive rust-colored appearance, Mars holds a special place in our imagination as a potential second home for humanity. Its dynamic surface, thin atmosphere, and tantalizing hints of water make Mars a key focus of scientific exploration and discovery. In this journey, we'll explore Mars' origins, features, atmosphere, and its importance in the quest to understand life and our place in the universe. The origin of Mars. Mars formed approximately 4.6 billion years ago, around the same time as the other planets in our solar system. It is thought to have been shaped by the same processes of accretion, where dust and gas around the young sun collided and merged to form planetary bodies. Like Earth, Mars went through periods of intense volcanic activity, tectonic movements, and impacts from asteroids. However, its smaller size and weaker gravity meant that Mars cooled faster, leading to the loss of its magnetic field and much of its atmosphere. Physical characteristics of Mars. Mars is a terrestrial planet, much like Earth, with a rocky surface. However, its unique features set it apart in many ways. 1. Size and distance. Mars is about half the size of Earth, with a diameter of approximately 6,779 kilometers, 4,212 miles. It orbits the Sun at an average distance of 227.9 million kilometers, 141.6 million miles, making its year nearly twice as long as Earth's at 687 days. 2. Surface. The surface of Mars is a study in contrasts, with vast plains, towering volcanoes, and deep canyons. The planet's red hue comes from iron oxide, rust, in its soil, giving it a fiery appearance visible even from Earth. 3. Gravity. Mars has about 38% of Earth's gravity. A person weighing 100 kilograms, 220 pounds, on Earth would weigh only 38 kilograms, 84 pounds, on Mars. 4. Polar ice caps. Mars has polar ice caps made of water and dry ice, frozen carbon dioxide. These caps grow and shrink with the changing seasons, hinting at active climate processes. Mars' remarkable landforms. Mars boasts some of the most dramatic and diverse landscapes in the solar system. 1. Olympus Mons. The largest volcano in the solar system, Olympus Mons is 21.9 kilometers, 13.6 miles, high, nearly 3 times the height of Mount Everest. Its base is roughly the size of France. 2. Valles Marineris. A colossal canyon system, Valles Marineris stretches over 4,000 kilometers, 2,485 miles, nearly the width of the United States. It is up to 10 kilometers, 6 miles, deep in places. 3. Impact craters. Mars' surface is dotted with craters, the largest of which is Hellas Basin, spanning over 2,300 kilometers, 1,429 miles. These craters provide clues about the planet's history and the intensity of early asteroid impacts. 4. Dried river valleys and lake beds. Ancient channels and basins suggest that Mars once had flowing rivers and lakes, raising questions about its potential to have supported life. The Martian atmosphere. Mars' atmosphere is thin and primarily composed of carbon dioxide, 95%. This makes it vastly different from Earth's life-sustaining mix of nitrogen and oxygen. Some key characteristics include thinness. The atmospheric pressure on Mars is less than 1% of Earth's, meaning water cannot exist as a liquid on the surface for long. Seasons. Mars experiences seasons due to its axial tilt, similar to Earth. However, these seasons are more extreme because of Mars' elliptical orbit. Dust storms. Mars is famous for its planet-wide dust storms, some of which can last for weeks and obscure the surface entirely. These storms are fueled by its thin atmosphere and temperature fluctuations. Mars moons. Phobos and Deimos. Mars has 2 small, irregularly shaped moons, Phobos and Deimos, named after the sons of the Greek god Ares, the equivalent of the Roman god Mars. These moons are likely captured asteroids from the asteroid belt. Phobos. The larger of the two, Phobos orbits Mars very closely and is gradually spiraling inward. In about 50 million years, it may collide with Mars or break apart into a ring. Deimos. Smaller and more distant, Deimos has a smoother surface and a slower orbit, appearing as a bright star-like object from Mars' surface. The search for water. One of the most exciting discoveries about Mars is the evidence of water. While liquid water cannot currently exist on the surface due to low pressure, scientists have found ice. Large amounts of water ice are stored at the poles and beneath the surface. Recurring slope lineae, RSL, dark streaks on Martian slopes, once thought to be signs of flowing briny water, are now believed to result from dry granular flows. Ancient rivers and lakes. Geological evidence suggests that billions of years ago, Mars had a thicker atmosphere and stable bodies of liquid water. The presence of water, past or present, is key to understanding Mars' potential to support life. Mars and the possibility of life. For decades, scientists have speculated about the possibility of life on Mars. While no direct evidence of life has been found, Mars has several characteristics that make it a promising candidate. Ancient habitable conditions. Mars once had a warmer climate and liquid water, conditions that could have supported microbial life. Organic molecules. NASA's Curiosity rover discovered organic molecules in Martian soil, which are the building blocks of life. Methane. Seasonal spikes in methane levels in Mars' atmosphere suggest potential biological or geological activity. The search for life continues with current and future missions, including the goal of returning samples to Earth. Mars exploration. Past, present, and future. Mars has been the target of numerous robotic missions, each contributing to our understanding of the planet. 1. Early missions. The first successful flyby of Mars was achieved by NASA's Mariner 4 in 1965. Since then, orbiters like Mars Global Surveyor and rovers like Spirit and Opportunity have revealed Mars' geological history. 2. Current missions. NASA's Perseverance rover is exploring Jezero Crater, searching for signs of ancient life and collecting samples for future return. The Ingenuity helicopter has demonstrated powered flight in Mars' thin atmosphere. 3. Future missions. Planned missions aim to return samples to Earth and prepare for human exploration. NASA, ESA, and private companies like SpaceX are actively developing technologies to send humans to Mars in the 2030s or 2040s. The dream of colonizing Mars. Mars is often seen as humanity's best hope for colonization beyond Earth. Its surface has resources such as water ice, and its day length, 24.6 hours, is similar to Earth's. However, significant challenges remain. Radiation. Without a magnetic field or thick atmosphere, Mars offers little protection from cosmic radiation. Temperature. Mars is extremely cold, with average temperatures of 62 degrees Celsius, 80 degrees Fahrenheit. Logistics. Transporting people and equipment to Mars requires advances in technology and infrastructure. Despite these hurdles, the idea of establishing a human presence on Mars continues to inspire innovation and exploration. Mars in human culture. Mars has been a symbol of war, mystery, and the unknown in human culture. Mythology. The planet was named after Mars, the Roman god of war, reflecting its blood-red appearance. Literature. Mars has been a popular setting in science fiction, from H.G. Wells' The War of the Worlds to Andy Weir's The Martian. Film and media. Stories about Mars explore themes of exploration, survival, and alien life, capturing our curiosity and aspirations. A gateway to the stars. Mars is more than a destination, it is a stepping stone to the wider cosmos. By solving the challenges of reaching and living on Mars, humanity takes crucial steps toward exploring the outer solar system and beyond. Mars reminds us of our enduring curiosity and capacity for exploration. As we study the red planet, we learn not only about its history but also about ourselves and our potential as a species. Conclusion. Mars, with its stark beauty and profound mysteries, is a world that both contrasts with and complements Earth. From its towering volcanoes to its potential for past life, Mars challenges us to think beyond our planet and envision a future where humanity reaches for the stars. As we look up at the red planet, it serves as a beacon of possibility, a reminder that even the most distant goals are within our reach if we dare to dream and explore. Saturn. The jewel of the solar system. Saturn, the sixth planet from the Sun, is often considered the crown jewel of the solar system. Famous for its spectacular ring system, Saturn has captivated astronomers and stargazers for centuries. But beyond its beauty, Saturn is a world of fascinating features, mysterious moons, and dynamic processes that make it one of the most intriguing planets to study. The origins of Saturn. Like Jupiter, Saturn is a gas giant, primarily composed of hydrogen and helium. It formed around 4.5 billion years ago, during the early stages of the solar system's development. Saturn is thought to have started as a rocky core, which then attracted massive amounts of gas and ice from the surrounding protoplanetary disk. Its massive size and low density make it unique. In fact, Saturn is the least dense planet in the solar system. Its density is so low that it would float in water, assuming you could find a bathtub large enough. Physical characteristics of Saturn. Saturn is the second largest planet in the solar system, second only to Jupiter. Let's explore some of its key features. 1. Size and diameter. Saturn has a diameter of about 120,536 kilometers, 74,898 miles, which is roughly 9.5 times that of Earth. Despite its massive size, Saturn's low density makes it much lighter than Jupiter. 2. Mass and gravity. Saturn's mass is 95 times greater than Earth's, but its gravity is only about 1.08 times stronger than Earth's. This means you would weigh only slightly more on Saturn than you do on Earth. 3. Rotation and shape. Saturn spins incredibly fast, completing one rotation in just 10.7 hours. This rapid rotation causes Saturn to bulge at its equator and flatten at its poles, giving it an oblate shape. 4. Atmosphere. Saturn's atmosphere is composed mostly of hydrogen, 96%, and helium, 3%, with traces of methane, ammonia, and other compounds. Its upper atmosphere is covered in bands of clouds, much like Jupiter, but the colors are more subdued, appearing in shades of yellow, gold, and gray. The spectacular rings of Saturn. Saturn's rings are its most iconic feature, earning it the nickname, the Ringed Planet. These rings are unlike anything else in the solar system and have been the focus of countless studies. 1. Composition. The rings are made up of billions of ice particles, ranging in size from tiny grains to chunks as large as mountains. These ice particles reflect sunlight, giving the rings their brilliant appearance. 2. Structure. Saturn's ring system is divided into several main sections, labeled alphabetically in the order of their discovery: A, B, C, D, E, F, and G. The largest and most visible rings are the A and B rings, separated by a dark gap known as the Cassini division. 3. Formation. The origin of Saturn's rings is still debated. Some scientists believe the rings are remnants of a destroyed moon or comet that ventured too close to Saturn. Others think the rings may have formed alongside the planet itself. 4. Dynamics. The rings are not static, they are dynamic and constantly changing. Interactions with Saturn's moons, gravitational forces, and collisions within the ring system create waves, gaps, and other features. Saturn's magnetosphere and weather. Saturn has a strong magnetic field, although it is weaker than Jupiter's. This magnetic field creates a magnetosphere that protects the planet from solar wind and traps charged particles. 1. Auroras. Saturn's magnetic field gives rise to stunning auroras near its poles, similar to those seen on Earth and Jupiter. These auroras are caused by charged particles interacting with the planet's upper atmosphere. 2. Storms. Saturn's atmosphere is home to powerful storms, some of which are massive enough to be seen from Earth. The most famous is the Great White Spot, a periodic storm that appears roughly every 30 Earth years and encircles the entire planet. 3. Temperature. Despite its distance from the Sun, Saturn radiates more heat than it receives. This excess heat is thought to be generated by the slow compression of helium in the planet's interior, which releases energy. Saturn's moons. A diverse family. Saturn is home to at least 146 moons, with 63 officially named. These moons are as diverse as they are numerous, ranging from tiny asteroid-like bodies to massive worlds that rival planets in complexity. 1. Titan. Titan, Saturn's largest moon, is the second largest moon in the solar system and even bigger than Mercury. Titan has a thick atmosphere composed mainly of nitrogen, with clouds of methane and ethane. It is the only moon known to have stable liquid on its surface, lakes and rivers of methane and ethane. 2. Enceladus. Enceladus is one of the most exciting moons for astrobiology. Beneath its icy surface lies a global ocean of liquid water, kept warm by tidal forces from Saturn. Geysers at Enceladus's south pole eject water vapor and ice particles into space, hinting at the possibility of microbial life. 3. Rhea, Dione, and Tethys. These mid-sized moons are covered in ice and heavily cratered. They may also have subsurface oceans, though less is known about them compared to Titan and Enceladus. 4. Iapetus. Iapetus is famous for its two-tone appearance. One side is bright and icy, while the other is dark and covered in a mysterious substance thought to be organic material. 5. Mimas. Often called the Death Star moon, due to its resemblance to the Star Wars space station, Mimas has a massive crater called Herschel that gives it its unique appearance. Saturn's role in the solar system. Saturn's massive size and strong gravity have a significant influence on the solar system. Its gravity helps shape the orbits of nearby moons and even affects the asteroid belt. Saturn's rings and moons also play a role in redistributing material within the planet's system, creating a dynamic and interconnected environment. Exploration of Saturn. Saturn has been a target for exploration for decades. Here are some of the most notable missions. 1. Pioneer 11. In 1979, Pioneer 11 became the first spacecraft to fly past Saturn, providing the first close-up images of the planet and its rings. 2. Voyager 1 and 2. The Voyager missions in the early 1980s revealed detailed images of Saturn's rings and moons, revolutionizing our understanding of the planet. 3. Cassini-Huygens. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, was the most comprehensive mission to study the planet. Cassini's data revealed unprecedented details about Saturn's atmosphere, rings, and moons. The Huygens probe, part of the Cassini mission, landed on Titan in 2005, providing the first-ever view of its surface. 4. Future missions. NASA's Dragonfly mission, scheduled to launch in the mid-2020s, will explore Titan's surface using a drone-like spacecraft. This mission aims to study Titan's potential for life and its unique chemistry. Saturn in human culture. Saturn has been a symbol of time and harvest in human culture for millennia. In Roman mythology, Saturn was the god of agriculture, from which the planet gets its name. Its stunning rings have made it a favorite target for amateur astronomers and a popular subject in art and literature. Conclusion: Saturn is more than just a beautiful planet, it's a dynamic world filled with mysteries. From its dazzling rings to its diverse moons, Saturn offers endless opportunities for exploration and discovery. As we continue to study this incredible planet, we gain not only a deeper understanding of Saturn but also insights into the formation